types of electricity: static electricity and current electricity. These are two types of electricity. First, static electricity. Static electricity is a type of electricity when electric charges develop but do not flow. Electric charges develop but do not flow. This type of electricity is called static electricity. For example, charges developed by a glass rod are rubbed with silk. When glass rod is rubbed with silk, it produces charges, but charges cannot flow. One more example of static electricity is rubbing of comb on cloth also produces charges, but charges cannot flow. So this type of electricity is called static electricity. Next is current electricity. In current electricity is a type of electricity when the electric charges that developed are also in motion. Electric charges develop and they are also in motion are called current electricity. Electrons can move. For example, electricity used in our home. Okay. Now next is Now let's discuss about electrostatic potential. So work done in bringing a unit positive charge from infinity to a certain point. What is electrostatic potential? Suppose infinity A is the infinity point and B is definite point in another electric field. Okay, so work done in bringing a unit positive charge from infinity to a certain point in an electric field is called electric potential. It is the work done in moving the positive charge from infinity to a certain point in an electric field of other charge is called electrostatic potential. For example, a unit of positive charge is at a point A at infinity and we try to bring it to point B, that is the electric field of some other charge. Okay, so the work done to bring this unit positive charge from infinity to a certain point B in the electric field is called electrostatic potential. Let's say charge Q2, so the work that we need to do in doing so is called electrostatic potential. So the work that we need to do in doing so is called electrostatic potential. Got it? The electric potential at a point is defined as work done in bringing a unit positive charge from infinity to that point. The potential difference between 2 points. The potential difference between 2 points is defined as the difference in electric potential at the two given point. Okay, the potential difference between 2 points, between A and between B, is defined as the difference in electric potential at the two given point. Okay, so what is the formula? Potential difference V between 2 points. Potential difference is denoted with V between 2 points is equal to work done by charge upon charge. V is equal to W by Q. Work is denoted by W and charge is denoted with the Q. So potential difference between 2 points is equal to work done upon charges. Work done to bring the charges from an indefinite point to a certain point in electric field. And the SI unit of electric potential difference is volt. V. 1 volt is the potential difference between 2 points. 1 volt is the potential difference between 2 points. in a current carrying conductor. When 1 joule of work is done to move a charge of 1 coulomb from one point to other, then 1 volt is equal to 1 joule upon 1 coulomb. So the potential difference is measured by means of an instrument called the voltmeter. Unit is volt and the SI unit of potential difference is volt, and the measuring instrument is called voltmeter. Let's take an example, numerical. How much work is done in moving a charge? How much work? Question mark. How much work is done in moving a charge of 2 C means coulomb across 2 point having a potential difference 12 volts. So we know the formula. What is the formula? V is equal to W by Q, and we have to, now this time we have to find out work. So we will be it is multiplied V and Q. W is equal to V into Q, 12 into 2, then work unit of work is joule, so 2 joule. So how much work is done? 2 joule work is done moving a charge of 2 coulomb across 2 point having a potential difference 12 volt. Got it? So these are all about electrostatic potential and electric potential difference. Let's discuss about circuit diagram. Electric circuits, a continuous conducting path between the terminal of a source of electric energy and other electric components along which the electric current flow is called an electric circuit. There are two types of electric circuit, closed and open circuit. A continuous conducting path between the terminal of a source of electric energy and other electric components along which electric current flows is called electric circuit. Now what is open electric circuit? If the circuit in which electric contact is broken, suppose it is broken from here. Here switch is used. Switch is also used as a to break or open the circuit or close the circuit. It is a circuit in which electric contact is broken at some point such that no current flows through the component of the circuit is called open circuit. Electricity cannot move through the open circuit. And the closed circuit, the circuit in which all the components of circuit are joined to one another such that a continuous current flows through them is closed circuit. Some electronic device with symbols used are rheostat. It is defined as the variable resistance. It is connected to change the current in the circuit without changing the voltage source like cell, etc. So rheostat is defined as a variable resistance. It is connected to change the current in the circuit without changing the voltage source. Galvanometer, it is a device used to measure very small amount of current as it has very low resistance. Here you can see the symbols. Electric cell symbols, a battery symbols, plug key or switch symbol, play key, a wire joint like this symbol, wire crossing without joining, electric bulb symbol, a resistor of resistance R symbol, it is resistance symbol, variable resistance of thermostat, this is ammeter, voltmeter. Resistance and Ohm's law. Ohm's law, the current flowing through an ohmic conductor is directly proportional to the applied potential difference between the two ends of the conductor. The current flowing through an ohmic conductor is directly proportional to the applied potential difference between the two ends of the conductor. Here you can see the circuit diagram. Cell, ammeter, voltmeter, and connecting wires. This is the diagram of circuit. Now let's talk about resistance. Resistance is a measure of the opposition offered. Resistance means opposition. It is a resistance is a measure of the opposition offered to the current. It offers opposition to the current flow in electric circuit. It is a measurement. It is measure of the opposition offered to the current flow in electricity. It opposes the resistance oppose the current flow in electric circuit. Okay, so what Ohm's law states: under constant physical condition like constant temperature, pressure, etc., the current flowing through a conductor like metals are conductors, so through a conductor, current flowing through a conductor is directly proportional to the potential difference across the conductor. Here you can see the formula, where R is constant for the given conductor at a given temperature and is called resistance. Resistance is the property of conductor. Resistance is the property of conductor which result the flow of electric current through it. SI unit of resistance is ohm, and ohm is denoted by this symbol. Ohm, this symbol is the symbol of ohm. R is a symbol of resistance. It is equal to the flow of 1 ampere of current through a conductor between two joints having potential difference equal to 1 volt. This means 1 ohm is equal to 1 volt divided upon 1 ampere. So from the expression of Ohm's law, it is obvious that electric current through a resistor is inversely proportional to resistance. This means electric current will decrease with increase in resistance and vice versa.